So continuing on with absolute value functions, there's something that we didn't really get a chance to talk about, and that's what if the coefficient on the x term isn't 1 or -1? What if it's some other integer or some other number? So let's look at that. So let's take some example. I'm just gonna make one up. So if we have y is equal to um, negative absolute value of 3x plus 2, close absolute value plus 1. Okay, so in this case, our coefficient on the x term is not 1 or -1, it's a 3. So this is actually going to change a lot about the function, and our translations won't be able to be applied as naturally. So what we're going to do first is find the vertex, and then when we find the vertex, then we're going to graph it from there. So to find the vertex, we want to figure out what x value we can plug in to this equation so that it eliminates our absolute value term and leaves nothing but our constant term. Now for this problem, that is going to have to be some x value that will eliminate this positive 2 and make this quantity to be 0. Well, I know it must be negative, and I want to cancel out the 3 with a 3 in the denominator and be left with a -2. So our x value of -2/3 should work. So if I plug in -2/3, and I have the function at -2/3 is equal to negative absolute value of 3 times -2/3 plus 2, close absolute value, plus 1. Okay, so this 3 cancels with this 3, and we're left with -2 plus 2, which is 0. Absolute value of 0 is 0, -0 is 0, plus 1. So we're just left with 1. So our vertex is going to be at the point -2/3, comma 1. So now that we know that, we can actually graph our vertex. If I just make a tick mark over here at -1 on the x-axis, right around here would be -2/3, put 1 for our y, and make a point, and here we are, we have our vertex. Now the next thing that I can do to graph this function is that we can choose an x value that is a little bit to the left or a little bit to the right of our vertex. The other option is that we can try to figure out what the y-intercept will be. If we are going to do that, our y-intercept is when x is equal to 0. And I think that's what I'm going to do. So I'm going to find our function at x equals 0. And if we plug this in, we're going to be left with negative absolute value 3 times 0 plus 2, close absolute value, plus 1. And then 3 times 0 is 0, plus 2, absolute value 2 is 2, -2, plus 1 is -1. So we're left with -1. So our y-intercept is going to occur at a y value of -1. So I could put -1 here and make a point. Now I already know that my right side of my function is going to look like a line that passes through these 2 points. So I can graph that here. And the other thing that I know is that absolute value functions reflect across the axis of symmetry that vertically passes through the vertex. So in this case, if I were to draw a dotted line through the vertex, our graph would reflect across that line, and I could just easily graph that. The other way that we could do is we can try to plug in like -1 for x and see what that is. But in the end, it will give us a value that just reflects across the axis of symmetry. So if we did plug in -1, we would get -3 plus 2 is -1. Absolute value of -1 is 1. but then the negative sign makes it -1 again, and then we're left with -1 plus 1 is 0. So it's actually going to be our intercept here on the x-axis, and our point here is going to be -1, comma 0. So I can actually graph that. And there we are. We have our graph of our absolute value function where the x has a coefficient that is not 1 or -1.